right, awesome. Thank you so much. Thank you all for joining us today. My name is Terry Damiba. I'm a data scientist and developer advocate at Quadrant. These lights are very bright, so I'm going to try to look up at you, but I might just be looking down. Please don't take it personally. First, just want to say thank you for having me here. It's been really cool meeting the search community. This is my first Haystack. And yeah, just a community that's really humble, eager to learn, and eager to teach as well. So always cool getting to meet a crew like that. So today I'm going to be talking about a new brainchild that Quadrant is going to be releasing. And this is part of our effort to start releasing our work earlier on in the process. So MiniCoil isn't even available on Fast Embed, but it is available on our GitHub, so you can go check it out, play around with it, benchmark it, see what works for you and what does not. And the basic idea here with MiniCoil is, what if, in addition to the power and the reliability and the speed of BM25, we could introduce a little context for those words so that BM25 didn't have to just rely on that word matching. So I'm going to get started here. Terry Damiba, data scientist at Quadrant, and let's get started. If the clicker works, let's see. All right, cool. So this is going to be the only slide about Quadrant, because one of the cool things about this product is actually you don't need a vector database for it. As long as you have an inverted index, it's going to work. But obviously, Quadrant is a vector database, so we work in HR, ad tech, dating. We do search systems, RAG, recommendation, anomaly detection. Think of search at scale. So if you think about things like social media, Disney, AI platforms, those are some of our customers. So my colleague who lives in Frankfurt or Munich, I'm sorry, Jenny, is actually the creator of MiniCoil. And the way that she thought of it is, there was this meme going around that she told me about, which is asking people how often you think about the Roman Empire. And apparently that's kind of like the ideal, is that people want to be in the Roman Empire. And that's the way that I think sometimes about this perfect search, right? Where everyone wants a search where you have that interpretability, you know why the results were shown, it runs fast, you have accurate results, right? We just want everything perfect, it's cheap, blah, blah, blah. The harsh reality is that's just not possible, right? But we came up with this idea for MiniCoil where we asked ourselves, okay, it's not possible to have everything, but can we just give BM25 a little nudge by giving it some context so that it can get us more relevant and accurate results? And the idea here was, what if we turn these words into 4-dimensional vectors? You can also use 8 or any other number, but we really wanted to see how much you could get out of just the 4-dimensional vector. So the whole idea here is basically, instead of just passing in the word, we're going to pass in the word, and then we're also going to add in those 4-dimensional vectors. If they don't have the 4-dimensional vector because it's not in, or we don't train a model on it, then we're just going to fall back to BM25. So just quickly here, I want to walk through the agenda. We're going to do motivation, BM25. Oh, my slides are not moving. 1 second, sorry. So that was my cool, you shall know a word by the company it keeps. The context of the word, of course. And then in terms of the agenda, we're going to talk quickly about the motivation for the project, BM25 recap, because we know and love BM25, explain the MiniCoil concept and the 4D vectors, walk through the architecture training pipeline, talk about advantages and benchmarks. Then I'll walk through a demo, talk about how to extend, Q&A, and get out of here. So this is our feelings on the current options that are out there. And you see we start out with Word2Vec, we go all the way to, we go all the way to late interaction Colbert and the sparse encoders. And basically what happens is anytime we move into a new process, we're solving a problem, but we're also creating a problem. So for example, these sparse encoders like Deep Impact weren't too good out of domain. Things like Splade, because of that document expansion, it's going to get you issues, whether that's with debugging, because all of a sudden you're getting tokens that are fed in that you're not familiar with, or it's because it's just going to run slower because there's more tokens than the user actually put in. And then coil, which MiniCoil is actually based off of, the problem was the storage overhead, right? Because it's so big. So we decided, hey, let's just try to project the information down to those 4 dimensions and see, can we still get some kind of benefit from it, right? So this is BM25, our old favorite. Everybody loves BM25, and I think BM25 is cool because it's reliable. It's been around for 25 years, and we know that it will do what its assigned job is. And its assigned job is find words. The problem, of course, with this approach is if I ask you to close your eyes and I say bat, do you think of something with eyes or do you think of something you would swing? BM25 doesn't know the difference, right? So the idea is, how can we let it know the difference between a fruit bat and a baseball bat? Our idea, and also one thing to keep in mind, is this idea of collapsing stems. So if you were looking at something like calculator and calculating, those aren't the same thing, but in a traditional model, they might get both brought down to calcul or something. So you're losing information there as well. Clicker. So I don't know which bat you thought of in your head, but of course, by giving the sentence a little context, all of a sudden, if I had said, think of a baseball bat in your head, no one's thinking of this bat. Looks a little creepy, actually. I'm going to go to the next slide. So here I have the classic example of hybrid search, right? And this is basically supposed to give you, got loud, supposed to give you the best of both worlds. And usually when someone tells you, hey, this thing is perfect, gives you the best of both worlds, we know what that means, right? There's some kind of trade-off that you're missing out on that you're either not familiar with or you're about to find out. But if you're not familiar, basically at the top, we've got BM25, our old favorite. And then we also are going to combine that with some kind of relevance score. And by combining these two things, all of a sudden, you can not only find out how many times Hermione is mentioned in Harry Potter, but you might be able to find out how many times she got mad at a professor, right? Those questions that the just text search wouldn't be able to capture as well. So if we look at this slide, and I'll even go back briefly to this slide, where you can kind of see the problems that came with each different model that we started introducing. Now, if we go to this slide, you can see the benefits, right? There's a reason why we moved to Splade and we moved to Colbert and all of these things, right? We're going to be talking about sparse encoders today, so I'm going to focus on Splade. But the idea of we need to keep evolving, we need to keep coming to conferences like this and just keep trying to build new stuff, because each of these models has trade-offs with each other, but when you look at the adoption rates, you're going to see that some are much more popular than others. So the question is, if you're looking for the kind of search that maybe the word context isn't going to be too varied, right? One of the very interesting things I found out while I was researching for this is there are 65 definitions for run. And you when you think about it, you're like, well, that doesn't really make sense. But then you start to think about it and it's like, oh yeah, there's a lot of different ways you can use the word run. So if you had a word that is going to be used that many ways, of course, if we're doing a 4-dimensional vector, it's not going to be able to capture the nuance there that well. But on the flip side, what do you get? Well, you get 4-dimensional vectors, which are going to run super fast, scale, great, perfect speed, and it's backed by BM25, right? So you have that reliability that BM25 offers. So how MiniCoil works is we're going to take that BM25 formula that we know and we trust, and we're just going to add in these 4D context vectors. The 4D context vectors are simply going to be those 4 cells inside of the sparse vector. So yes, the vector is going to get less sparse, but only by 4. And if we don't have any kind of training data, we're just going to fall back to the BM25, which would be that 1 cell. So just want to reiterate kind of this idea of homographs, homonyms, stems, tokens, words. Fruit bat versus baseball bat, different things. But how do we find the average between fruit and bat, right? When we're trying to debug our search, or maybe we're even just trying to find out, does our search work? It's pretty difficult to find that middle. And then the same example from earlier, calculator, calculating. One is a noun, one's a verb. They're not the same thing, right? You don't want those showing up when people are searching for something. But if we're just going to cut these both to calcul, all of a sudden they're going to show up. So the big question that I had when I saw this is, why 4? What's special about 4? And the answer is, we just love the Fantastic Four. So we decided to go with 4. Now, we went with 4 because, we went with 4 because A, it is a flexible number. We also tested with 8, but we found that with 4, we were already getting results that were moving in a positive direction. And the goal here is not to replace the other tools that excel in vocabulary mismatch, right? The goal here is to create a fast, scalable, generalizable, right? That's not going to be locked into one domain and can still give you better results than if you just ran a normal search. So how does MiniCoil work? Well, we kind of took the best of everything here. We tried to minimize the worst of everything here, and we put it all together to give us this. So basically, we're going to be combining that. Oh, I have a laser pointer, I forgot. We're going to be combining that BM25 TF IDF with coil, except we're going to make it small, and that's why it's MiniCoil. Because while coil is great, it's really big. So if you're trying to run things at scale, it can start to become an issue. So now let's talk a little bit about the actual architecture of this coil model. At the top here, we have a projection for the word bat. And actually, I'm going to go to this slide because I think it's an easier way to see. So you can see here at the top, we've got a baseball bat. So this PCA piece is the baseball bat. I shouldn't say PCAs, but this UMAP piece is the baseball bat. And then here we see fruit bat and cave bat are close together. They're still separate, but as we expect, they're still different, right? Because fruit bats typically should do different things than cave bats. And if I search for, bat in a cave, you should probably show me a cave bat. And if I search for bat in a forest, you should probably show me a fruit bat. But you see that they are still together close there. And this is kind of our way of saying, I think this was 8,000 sentences. And we can see here, not only does it look like a bat, which is just insane, like what are the chances? Also, there's clearly 4 groups or so, right? We've got like this little group here, this one up here, that one. And yeah, it's baseball bat, fruit bat, cave bat. And obviously there's other kind of bats, and it's not going to be perfect. But all of a sudden, if I go back here, we can get information on what's going on. So what we do first is we're going to have that role model, which is mixed-bred AI. And then down here, we've got genus small models. So what we can do is basically take the contextualized embedding and then project it down to 4 dimensions. How do we project it down to 4 dimensions? We're going to use triplet loss. So if you're not familiar with triplet loss, If you're not familiar with triplet loss, it's basically this idea that you can train models by looking at the data inside of them. Or I shouldn't say the data inside of them, but you can, for example, compare positive samples with negative samples, and then you can also have a function that's going to look at the gap between the positive and negative. And then you also have like a margin value that's going to keep the samples far apart. And through this process, what we were able to do is basically take that mixed-bred AI embedding, put it in a GINA embedding, and then get all the way down to those 4-dimensional embeddings. So that's kind of the special sauce here, is this idea of using triplet loss to project down the embeddings to 4 dimensions. And then, I'm on the wrong slide, sorry. So then, now that we've seen the pictures, I'm going to show you some text, talk a bit about the architecture. In ours, we use the Gina mixed bread, but it is agnostic to the transformer. So you can use any transformer you want. If you like instructor, if you like whoever you like, you can plug that in, do what you got to do. And then the word mapping, once again, it's going to work on the words, not just the subword tokens. So if we look at a word like retriever in MiniCoil, we're just going to grab retriever. And obviously that, like, there's a difference between a golden retriever and someone who retrieves stuff, I guess, as a job, right? But we see here the tokens, it's going to kind of have those pound signs and break it up into different pieces. And then the down projection model, once again, we're going to take each word in the vocabulary, give it its own model, project it down to 4 dimensions. And then if for some reason that word isn't in our model, we're just going to fall back to that first cell, which is just going to be the BM25 values. And then each 4D vector is then multiplied. But one thing to keep in mind is we're just adding those 4 cells to our sparse vector. So it's not like we're creating like another table where these 4 dimensions live. They're still in the sparse vector. We're just adding 4 more, making it less sparse, but we believe that the trade-off is worth the juice is worth the squeeze. So basically, yep, we're creating this new sparse representation. It's semantic, it's interpretable. You can tell what the difference is between fruit bat and cave and a bat. And then finally, of course, going back to hybrid, what happens is out of the result of this, you get a perfectly working vector that you can use for any kind of inverted index search, right? So as I mentioned in the beginning, I work for Quadrant, we're a vector database, but you don't actually need to be using a vector database to implement this, right? And the big takeaways that we got is the validation loss closely matches the theoretical lower bound. What does that mean? That means that in our model testing, we used mixed bread and Gina small. That has about, it has a 17% gap. Our model, which is 4 dimensions, also showed 17%. So what we're seeing basically is that the model generalizes across the examples, and even though it's only 4 dimensions, we're still getting the same basically performance, right? And then here we have a graphic that shows you kind of how this works. So you can think about someone searching for fruit bat. As I mentioned earlier, how the heck do you find the average between fruit and bat? Well, you've got the transformer of your choice, right? You can plug it in here. So in our examples, we were using mixed bread, but you could use whatever inference model you want to use. And then we're going to get the contextualized embedding of bat, and we're going to get the contextualized embedding of fruit. So now we're going to take those projections and like almost kind of lay them down, if you will, so that we can have that data that we have here. We also have the dense embedding of fruit bat. So this is the inference process that you can see right here, right? This is kind of the inference infrastructure. And as a result of this, we can do that hybrid search thing that we love, combining the power of BM25, which we know crushes it when it's just searching words, with a little context boost so that it can get some better results. And we ran this on the MS Marco dataset. And it's important to note with these benchmarks, we did not train on MS Marco at all. This is us just out the box letting MiniCoil rip. And you're seeing that it performs better on the MS Marco. But I really want to emphasize that this project is not about benchmarks. We're looking for practical, holistic, applicable, deployable, scalable solutions for problems that people have. And we're also looking for feedback from the community in terms of both our implementation. If you have any ideas, if you have any benchmarks that you don't see the performance you want on, we want to hear from you. We're bringing you in. I mentioned this in the beginning. This isn't even available on Fast Embed. You can use it open source on GitHub, but we haven't even released it as a product yet because we just want to get the community in as early as possible so that you guys can help us with the development. And we're going to be releasing more resources about this, but we want to get people basically to see a sneak peek what we're working on so that if you have an idea that can lead us the right way, we can hop on that right now as opposed to 6 months from now, right, when everything's clean and polished. So I just want to briefly show you guys a demo. And here, we're going to go back to our bat. Of course, I had to do it to you. And what you can see here is, let me full screen this bad boy. What you can see here is basically we've put in some sample documents of text that's going to have bats. And if you look here, this is every time we see the bat, but then these words in white are kind of like the context words that we've decided are important to whatever bat is, right? And if you look over here, I'll have to hover actually for you to see this. So that, my eyes don't work, but I believe is talking about the bat, the animal, and that's purple or that's red. And then if I were to go down here, I can't see it, but I think this is going to talk about something different. So the idea here is basically you're clustering the points based off of the context. And then this demo basically shows you what it looks like with different search terms, right? So vector is a really good one because you can imagine people come to our documentation and they type in vector. And it's like, well, what do you show someone who types in vector on a vector database site, right? It gets a little weird. So this is part of why we started thinking about, okay, how can we maybe contextualize the search? Because a lot of people now expect great results as if you're in their mind with one query, right? I was here for, I believe it was Doug's presentation, talked about red shoes. Like, people just want to see red shoes. They don't really care about anything else, right? So how do we make sure that they can see those red shoes is the questions that we're asking ourselves, right? And also, how do we make it practicable, scalable, and not domain specific, right? Where each time you want to deploy something, you have to just create this crazy system that just works for that system. And then anytime you have a tweak or want to do something new, you have to start from scratch. I'm a big believer in keep it simple, stupid. I think a lot of problems, issues, really just sitting down with someone and saying, hey, what is it that you want to accomplish with this tool? Sometimes can get you the most results as opposed to like deploying AI and doing all this cool, vector stuff. Sometimes they don't need all that. They just need an answer to their solution, right? So I'm a big believer in keeping it simple, and I think MiniCoil kind of builds on that in terms of we're keeping it simple, right? It's just 4-dimensional vectors. We think that we can provide some information by giving BM25 access to that, and we're seeing that it's giving fruitful results so far in our testing. So in terms of MiniCoil strengths, these are kind of the things that we're highlighting. First of all, agnostic to the embedding model or transformer. You can use anything that you want. If you have a custom one or if you have one that works specifically well for you, bring it on into Quadrant. Simple architecture. One word, one small trainable model, super fast inference, right? That's what Quadrant's all about, is going fast. And also, it should be noted that we found here that the validation loss matches the theoretical lower bound. So it's not even like you're losing much, if anything, from going to that one word, right? But you are gaining a lot of that inference. Then the third box might be the most important one, right? You don't need labeled training data. You can just avoid all of those relevance objectives. You don't need to have a million things in your collection. You don't need to worry about overfitting as much. And then finally, this vocabulary becoming extendable. So the fact that new words can be added to the vocabulary without retraining existing models, if anyone has had to do that, it's not the most fun. So just being able to plug and play with words, retrain the models, everything's small, everything's has fast inference, and everything's modular. So if you ever need to pop one out, pop one in, it's really not that big a deal. So that is my presentation. My name is Thierry Damiba. I will now open the floor for any questions.
Thank you, Thierry. Let's start off with a question online. So Kevin Lang on online asks, is the 4D vector for terms generated at both query and ingestion time? And if it's generated at ingestion, is the 4D vector incorporated into the usual sparse vector reverse lookup table?
Yes, exactly. That is the benefit of this process. You can use it with your inverted index, plug and play. You're good to go.
Great. Questions in the room? Sorry, I took my glasses off.
So just curious, you mentioned about sparse vector along with this 4D vector used during training. So what is that sparse vector? Is it just one hot encoding of all the tokens in that document, or like where is this 4D vector being sort of combined together with the sparse vector? I got slightly confused there. Yeah.
Hopefully, and let me know if this explanation needs a little more context, but the idea is you're going to add those 4 cells to your already existing sparse vector. If you don't have the 4D representation, then you're just going to take that first cell that you would use for BM25. So it's not like you're creating a new situation with 4D vectors. The 4D vectors are living inside of your sparse vectors, making them less sparse, but the trade-off is that you'll be able to get that context from the words and not just text search.
And the sparse vectors are essentially just one hot vectors for all the tokens in the document, or?
There are projections down from the embedding model. So yes, to answer your question, yeah.
Any other questions? Great. Thank you, Terry.
Thank you for having me. If anyone has any questions, feel free to reach out. This was awesome. Appreciate you, Haystack.